Then I guess my job is to introduce the chair of the next session, David Bacon.
And also big thanks to Annie, because a conference or workshop like this is just huge for introverts like me, who never really take enough time to pop up and look around at what other people are doing. So I could say a few more words about myself, but I think in the interests of expedition, I would like to introduce our next speaker, whom I've also never met, but I've certainly been hearing about him for a long time, Micha Sharir. Micha, you might be in the easternmost time zone, and I'm probably in the westernmost time zone at this conference because I'm in Pacific. But anyway, it's all yours. Take it away. Thanks.
Thank you. I suppose I am. Okay, 1 minute.
Micha's already world famous. Otherwise, I'd probably tell you all about him too. But let's begin.
Okay. So I must say I was a little bit concerned about the time constraint that I have for my talk, which is only 15 minutes. I was rather nervous that I will not be able to say everything in time. I'm a little bit less nervous now, but but I'll try to stay within the time limit. So I'm really not. I'm really somewhat of an odd bird in this crowd because my exposure to SETL lasted about 3 years, as I was a fresh PhD student coming from a PhD in functional analysis in mathematics, and being snatched from the project by Jack Schwartz himself when he took me with him on his ride towards the next endeavor of him, which was robotics. But in the meanwhile, I enjoyed it as much as I could, even though I wasn't really prepared for working in compilers, optimizations, programming language, and so on. But I did manage to pull it through. I did not touch this subject because I moved to other fields for about 40 years. So I'm not sure I really know enough about it to present something that most of you probably know much more than me, but let me try to do it anyway, in terms of some nostalgia at least. And I will, the second half of my talk, I will mostly talk about Jack himself, which will have very little to do with programming languages. So again, Ed actually gave a very good presentation, so I can go quite quickly over it. The whole idea is that you want to write things concisely using set theoretical constructs, sets, maps, tuples, whatever, and you basically ignore all the low-level details. You overload operators, you do not declare variables, you do whatever you feel like, in the hope that your programs, your code will become simpler, more readable, and hopefully also more correct. And all the dirty work is left to the compiler, so which without the optimizer in runtime, it will use the runtime library to determine what's going on, because it will have no idea otherwise. The optimizer would and should help to make it better. And of course, execution without trying to do anything will be slow. I just, excuse me, I just copied a few programs from old papers that I found. This is Dijkstra's algorithm in quote unquote low-level SETL, because here we spell out the algorithm quite in detail, but as you can see, there are no declaration, no nothing, and we have no idea. For example, if you look at the map vel, first of all, we have to find out that it is a map. We have to find out its domain of definition, which are the vertices of the graph, the range, which are integers. We have no idea that this is indeed the case. We have to figure it out either during runtime by the runtime library, or the optimizer should and actually will detect many of these things. But you can write programs in a more compact form. For example, my favorite is this, I think Jack's favorite also was this one-liner of how to compute primes, and the second version will give you an n-cube algorithm, which obviously you would like to make more efficient in practice. And another program I pulled from an old paper, the transitive closure of a set S0 in a map F. So the while statement, if you look at it, is quite expensive because you need to iterate over all elements of the set, compute the range of all of them, make sure that it is not a subset of S. You would like to do something better. So the whole philosophy is that you write kind of in a carefree manner and hope that someone, the optimizer in this case, would clean the rubbish after you, so to speak. So what would you like the optimizer to do? I mean, you can do modest, not so modest, but still relatively modest optimizations that start with control flow, data flow, all those basic optimizations that are done in most optimizers. But peculiar to SETL, you would also like to do more advanced things like automatic selection of data, inferring data types, automatic selection of data structure, copy optimizations. I'll say only a few words about each of them later. But you might also look for really advanced things that would transform the whole algorithm, improving it by orders of magnitude. For example, for the transitive closure, you would like to transform it so that you don't have to execute the while loop every time from scratch, but not from scratch. But you notice that you can improve it by more or less differentiating it with respect to the change that the set undergoes as the while loop is executed. The current optimizer, this is too much for it, but there are papers that address it and try to do it in a completely formal manner. I'll say a few things about it later. So the SETL optimizer was written by Stefan Freudenberger with very little help of mine, I guess. It does the basic optimizations that most optimizers do, and it does the advanced optimizations that are peculiar to SETL or to equivalent higher level languages. And I'll just briefly touch upon these three things shown here: type selection, data structure selection, copy optimization. So type selection is quite an important thing to do because operators are overloaded, no types are declared. When you see a statement like z equals x plus y, you have no idea whether this is an integer addition, set union, tuple concatenation, or God knows what else. And you need to call the runtime library to decide for you if you cannot optimize it and settle the type in advance. And the optimizer does it by using flow analysis techniques that determine how these variables are set or used or copied and so on, and gives you, for example, figures out that this is an integer addition and sets you all the rest of the work. Data structure selection is more interesting. First of all, even if you know that something is a set, there is a large variety of representations that you could use. You could implement it as a hash table, a bit string, a linked list, an array, all kinds of other constructs, and the decision of which is the best depends on the use. An important notion in the optimization of that is related to this is the notion of bases. So this would just be a domain of entities that are used by the variables of your program. you do not, you could, but you do not declare them in advance, and the optimizer has to figure out that something like, aha, here is a base consisting of the nodes of the graph or something, and there are elements that, there are variables that are just elements of a base, there are variables that are subsets of a base, maps from one base to another, tuples of elements of a base, and so on. Figuring out all of this is a big step in the optimization, combined with the decision of which of the implementations of sets and such are preferred in the particular context. So this is something that the optimizer can do and does. And copy optimization, as was already mentioned, SETL has value semantics. So if you assign a complex object to X, you basically have to copy it into X. But you'd rather not copy, but just store a pointer, because that would make it infinitely, not infinitely, but let's say infinitely more efficient. And but you have to be careful, because if later you're going to modify complex object, then X doesn't point to the right thing anymore, and you have to copy it then. And the optimizer does it for you by figuring out whether complex object is going to be modified or not. And if not, it allows you to store a pointer. But in trying to do this transitive closure optimization, there you need to do something that beyond of the current things, although again, you can state and manipulate it quite formally. And it's a notion called formal differentiation, already mentioned. Originally, I think Page and Schwartz did it. The whole idea is that you have a complicated expression that depends on, say, a set S, but S is going to change only by adding or removing an element or so, and then you want, quote unquote, to differentiate the complicated expression, so it would apply only the difference, or the derivative, if you will, of the operation. And this is what you get in the second version of the program, that the while loop now becomes very simple, and the updates that you need to do are much more benign than the original execution of the while loop. Again, in the little time that I have, I don't think I have much more, or can afford to say much more about it, let alone the fact that I don't remember anything by now, as I told you in the beginning. So let me move to the second part of the talk, and kind of some nostalgia about Jack. So first of all, it's time that we see the person in person, so to speak. This was taken when he was visiting Tel Aviv University quite a few years after the SETL project. So again, you must remember that I landed into the SETL project as a fresh postdoc with very little introduction to programming language, optimizers, and whatever. And I actually felt that I'm going down from the heights of functional analysis, but Jack was there, and his presence and guiding and mentoring was really very powerful for me. I actually believe, I'm sure I'm not the only one, but he was a role model to me that I try to imitate as much as possible with very, very, very limited success. It was impossible to do it, obviously, but still something I managed to run along and absorbed a lot of good habits from him, and noted a few bad ones too. I don't have time to go over all of them, but here is a very partial list. The first two are very important to me. He had really an urge that everything should be rigorous and detailed. So nothing should be kind of swept under the rug, and things should be worked out with precision. It turned out they tended consequently to be quite long because if you want to spell out everything, but that was something important that was important for me. The other thing is his general attitude, what I call hands-on approach. So he would do everything. He would have an idea and then he would sit down and write it. Actually, in full detail, he would hand you a draft of a paper that was draft, but very close to a full paper, or SETL code or system design or an algorithm, whatever, and you really had to do better, to run twice as fast, if you will, if you wanted to become part of it. I would like to mention lower level details, but still quite peculiar. Of Chinese food is something that was very strong in him. There was a Sichuan taste restaurant, if the old gang still remembers it, that used to drag us to lunches over there. What I think is important to mention, that I'd like to mention, is his fondness for history books in China. So he was really a very kind of amateur, but very serious student of history, trying to whatever. Books is quite phenomenal, as many of you know. He could read everything at the speed of light, more or less, and understand everything, and that was quite amazing. China was the soft spot in his heart because he admired the country, especially the older version of it, because according to him, you could climb up in the system there without any social background, just by being smart and passing an exam. That for him was a very important feature. Let me skip the other two, which are a little bit more of vices, which unfortunately, at least the last one, verbosity, I also learned against my better will. But what I want to mention is my interaction with Jack took place outside SETL most of the time, because Jack had this incredible ability, urge, whatever, to move between fields. He started, of course, and in an obituary when he passed away, someone called him a restless mathematician, which I think is a very good description of him. So mathematics, of course, he did a lot. I have one volume of Danforth Schwartz's Bible with me, but he wrote about anything, relativity, finance, whatever you will. Then, of course, came SETL. I mean, there were several stages before when he went into programming languages earlier on. Program verification and automatic proof systems was very close to his heart till his end, more or less. But after SETL, he moved into robotics, where I stayed with him for quite some time. But that was not the end of it. He then moved to ultra computers and parallel computing, and then to multimedia, and then to bioinformatics, and so on and so forth. And in each of them, he actually invested a lot and did a lot, established full projects and labs and so on. But robotics was my main connection with him, because he took me from SETL to robotics by simply dropping on me one afternoon a complete sketch of an algorithm for complete collision-free motion planning for a line segment amid polygonal obstacles in the plane. I joined him, but this button evolved into a full jacket. First, we had the sequence of papers on the piano mover problem, where Jack played the dominant role, and this sequence laid down the infrastructure for algorithmic motion planning in robotics. But then Jack went on to establish the NYU Robotics Lab, which functioned for almost 10 years, or probably more. I was there for 4 years, which were the best research years of my life, working with and alongside Jack. And then I moved to robotics computational geometry and stayed there ever since. Jack kept moving between topics, as I mentioned, but we kept in touch until his passing away. And let me end by just citing what Peter Lux wrote in the obituary written in an AMS volume. Let me read it to you. Hans Bethe once said, only half in jest, that von Neumann's brain was an upward mutation of the human brain. The same could have been said about Jack. We shall not see the like of him for a long time. And that probably is quite true. And I thank you for your attention. That's it.
Thank you very much, Micha. That was very interesting, and yes, actually rather moving too.